Okay. Yeah, good morning. Uh, First of all, I want to ask regarding your assessment. How far we go? I mean, the individual assessment and the group assessment. Society. Hmm? How about the group? Are they cooperating with you? Oh, you have some sort. So, books. Who are? Do you have anyone here from your group? Okay, yeah. How far are we going on you? But it won't take you long. So within a week, you should be able to finish it. Once you're able to have your design and you have your analysis, then the rest is simple. Please don't wait until the deadline because the deadline is fixed and I can't change it. So try and finish it on time. And don't forget, you still have your individual what's the name, right of essay also. So those are the two assessments we have there. Don't have any other assessment. So please. Reason is that if you come later to tell me that you want me to push the deadline forward because you won't be able to because I already submitted on the 4th of April as the deadline, the submission week. So please, then if you have any problem, just let me know. Exactly. So now, we want to continue with another aspect of food engineering technology, and this has to do with food processing, extrusion technology in extrusion technology in food processing. Extrusion technology in food processing. Now, what is extrusion? I think some of us have heard of that word. What is extrusion? Have you heard of this word before? Extrusion? Malik, have you ever heard of the word extrusion before? Extrusion? Do you eat noodles? Eat noodles. Have you ever asked yourself how noodles is made? Compression? Okay. Can you speak louder? It will be in the solid form. Okay. When through a compressor machine, yeah, machine so get the threads coming out. So that method is what called extrusion. So some of your noodles and some of this spaghetti and the rest is made from extrusion method. And a description of this is likened to when you have when you're inside the bedroom and you want to brush your teeth, right? What do? You press the toothpaste, and the way this what's in it, the paste is coming out. You understand? That method alone, as simple as it is what we call extrusion. Exactly. So now, do you know how when you squeeze toothpaste, it comes out in a long, funny shape, right? Or when you push a plate dough through a toy, it makes a star on noodles. So we have different kinds of noodles with different shapes, right? So those different shapes you see in the market, they are made through what? Through extrusion technology. So there are different applications of extrusion technology. But one of the application is in food processing. We use extrusion in electrospinning, that is in additive manufacturing, that is outside this module. We use it in plastic or polymerization, all this plastic molding and things like that. But the most important thing is that it is used in what? In food processing. We also use it in mixing. We also use it in extraction process, especially from my former research. I use it in the extraction of protein from grass. So it has many applications. Exactly. But today, we only focus on the application of extrusion technology in
food processing. And may I tell you, if at the end of the day you want to start your PhD, you can use this application for different research. Exactly. So that is extrusion technology. So in food factories, they mix food like flour and water, right? Make it warm and squishy, and then push it through a tiny hole to make a fun shape, like cereal, pasta, snacks. And when it comes out, it cool down and become yummy food. I think you have many of these, right? An example of this is this. You see this the kind of food like this. Let's see. This, all these frog lobes, what's the cheese ball, right? Many of you like cheese ball, right? All those funny shaped noodles, right? All those spaghetti, they are processed with the head of what? Extrusion technology. And in extrusion technology, we have this extrusion part. This extrusion part has different functions. The first part is what we call feed popper. We have the plastic pellets. That is if you are dealing with plastic. You see what I'm telling you now? The diagram I gave is for plastic production, right? But we can actually use it in what? In food production, right? Let's say we put our flour inside here, right? Then you have your heater. It will eat it, at least to become soft. Then there will be a rolling. As it rolls, it's more or less like you are trying to grind it. Grind it. Don't worry, I've worked with this before, so I know how it works. So it's more or less like you are grinding, grinding, grinding. It comes to a place where you have a small tubular. You understand? Just like your piece, right? All this one will be coming out small, small. Depending on this extrudates. Exactly. So it can come in different structure, like this, just like you have this, right? So that is extrusion process. And looking forward, looking at different snacks we eat outside, we discover that we have many of these snacks outside, right? If you go to B&M or you go to Tesco or Sainsbury's, you will see all this. All those different snacks you have, they are produced using extrusion methods. In as much as you have shape that you are dealing with, then we use extrusion technology.
The extrusion also used for using bottle container or
Yes, I think.
because in the factory,
Okay.
they can be new bottle or the container. Recycle the old plastics and comes to the machine. Then they shape it and made it make a new plastic bottle of the container.
Yeah, you're right. Like based on the picture I showed you here, this is in what? This is in plastic production. You understand? You have a pellet, then you put it inside the hopper, and once you put it inside the hopper, it's eaten, then you are able to get what? You are able to get these different shapes. So the shape of this nozzle will determine the shape. I mean, this shaping die you have, the shape will determine the types of products you are dealing with different shapes. Some will have star shape, ring shape, bottle shape, and so on and so forth. And that is the extrusion process. So let's go deeper into what are the mechanism of extrusion process. So today we deal with introduction, advantages of extrusion, what are the merits and popularity of extrusion cooking. That is the application, where it is, where can we use it in food processing. Then the principle, that's the mechanism of extrusion cooking, and the classification of extruders, factor affecting extrusion cooking. And that's what we deal with today. Do we have anyone here dealing with extrusion process for your individual cooking? And you are very lucky. So I want you to write it very well. Maybe smaller in chat, right? So now, looking at food items like this, I think this is most of us from India will understand this, right? Or from Africa, right? Then some of us that eat baby food, like chips. How many of us like chips? I'm like that. I like chips too, right? All these chips of different sizes, they are made using. It can be made using what? Extrusion process. Other process can be used, but for now we are dealing with extrusion process. Now, I've explained to you what is extrusion. In a layman language, extrusion is more like your toothpaste, right? If you want to brush your teeth, you pull out your toothpaste and you press it, and the paste comes out. The process by which that paint, you receive that paint, I mean, on your brush, that is the extrusion process. And we have different processes that works based on that. So, in extrusion cooking, is a modern cooking method that makes use of thermal and mechanical process. So thermal is heat, and what? Mechanical is what? Mechanical, right? So it means you are eating um, a food item or your raw materials, right? In the process of eating, you are rolling and what? Mixing until you have different shapes, right? So that is extrusion. So in which heat transfer, mass transfer, prior changes, and share are combined to produce effects such as cooking, sterilization, drying, melting. So this is telling you that, wait, this is telling you that extrusion process can be used for different processes in food processing, right? An example is that it can be used for cooking, right? It can be used for what? Sterilization of food. It can be used for drying. It can be used for melting. It can be used for cooling. It can be because now, okay, you mentioned cooling. Reason is that there are some extruder that works not based on heat. They works based on cooling. So we have a cooling machine beside it. So it will cool it to a lowest temperature. Do you understand? And once it cool it to a lowest temperature, you will use mechanical force to what? To grind it. We use it. You know why? The reason why is that when we put our food items inside, protein can easily be degraded, especially all those larval protein. I mean, heat sensitive protein. So instead of using heat, we use what? We use the cooling tower. So instead of heating it up, we cool it. And the cooling we are applying is not just normal cooling, refrigeration cooling. No, cooling to around minus 50 degrees. So when we have minus 50 degrees, you know how temperature will be, right? So we cool that food item to minus 50 or minus 20 degrees, such that by the time we are grinding, by the time we apply the mechanical force, don't forget there will be heat. So that heat will not degrade the thing. That is the reason why we are cooling. So that is one way. So we use extrusion also for texturing. If you want to obtain a particular texture of food, right? You can use extrusion method. Then we use it for conveying to move from one unit operation to another. It's also used for puffing, especially when you for product like cheese ball, right? For product like cheese ball, we can actually use extrusion to puff it, right? For mixing, for kneading, like this, right? For also for forming. So those are the different um, application or uses of what? Extrusion process. So these are the things I want to say. These are the things I want you to capture on your projects or your individual projects. So I want it explanatory that even if anyone from outside read your what do you call it, to be like a textbook, right? You give me the principle, you give me where it is used, different applications, right? In terms of food processing, then using different literatures, you can have like a table, right? To describe all those, I mean, where it is being used. Maybe Larry and told do this, Sai and told do this. So you understand that now? So that's what I expect from you. So it is important, it is an important food process in the manufacture of what? Pasta. The many of us will like pasta, right? Pasta, ready to eat cereal, snacks, and also in the manufacture or production of pet foods. If you have dogs, most of the time when you are walking your dog, give your dog your dog treats, right? Don't do like this. do something. All those pellets you see is produced using what? Using extrusion process. Do you have any question, please? Josiah, any question? Mukunda, why is your friend Mali sick? She's sick. Yes, yes, sir. So it's time my business, right? I must say I next week. It is well. Take care. Take care of her. But she's here, our father or mother here. Hmm? So let's continue. So that is the introduction part. Now, extrusion technology is gaining increasing popularity in the global agri-food processing. And I told you, like from my previous explanation, you can actually picture it. At least most of the time, I'm going to be at them this morning. You have varieties of food produced from this process alone, right? Because if you look at all those snacks all those children, small children eat, it's produced from this method. So that is the reason why it's an important technology. Without it, you can't have your noodles, you can't have your pasta, right? You can't have all this your what's the name? Potato chips, right? All those what's the name of this this one that is being pumped. Forgotten. Cheese ball, right? Like it, right? Cheese ball. So all these processes, I mean, this technology is used to produce some of these food items. So extrusion cooking technology are used for cereal and protein processing in food, right? I think I mentioned that, right? Then nowadays, consumers do choice for nutritionally rich, therapeutic benefit, and for attractiveness, especially in case of baby food. You see different. Okay, let me show you this. The one I show you. Okay, look at it. This looks good, right? So if your baby sees this, then they say, oh, this is colorful, right? Like my daughter, most of the time when she will say, oh, daddy, this is the one I want. You know turkeys? Tell me, you know turkeys. She likes turkeys very well. And those turkeys and the rest like that, they are made from what? Extrusion process. And do you know one thing about it now? As a food engineer, it's not about using the extrusion technology alone. It's how to use different shapes, different color to what? To attract a customer. Do you understand that? And that has to do with product formulation, product development, and the rest like that. So most of the time when you are dealing with new product development, especially for food items, you look at shape, you could look at the color, you look at the texture. The texture, what is what I mean by the texture? I don't know whether you have experienced it before, the crunchiness of all these snacks most of the time makes you buy them. But if today you buy one and it starts to crack, what happens? You will not buy that again. That's the texture. Do you understand now? So the technology behind this extrusion process determines the acceptability of your products, especially the food items. And that is the reason why you will ask me a question that where are we in all of this? As engineer, you must be able to design your process. And don't forget, you remember when we were dealing with parameter screening optimization, you remember that you can actually use that methodology to what? To produce new products. You know how much of this is coming in, right? How much of the heat? What is this rotation speed? All those parameters to a larger extent determine the quality of the product that is coming out here. You see the way I'm trying to connect what we did from that software with this. And that was the reason I said you can use it in different both food application, chemical engineering application, and even in food chemistry. Is that clear? So that is that about that. So now we have. So we already mentioned different. What's the name? The introduction. How extrusion technology can be used in new product development, like some of these kind of what's the name? This product, was it this series, the one you put inside your bowl and the rest like that. So all these products are made through what? Through extrusion process, and it gives different function. It can give cooking function, sterilization function, drying function, melting function, cooling function, texturing function, right? Conveying function, puffing function, mixing, kneading, and what? And forming. And that is, those are the different functions. Then now let's look into, okay, now just to obtain above mentioned designer food extrusion technology is used. You see food with different designs, right? So to obtain different design like cone shape, different shapes, I think there is one we use, especially in all this what's the name? This milk chocolate. You know that milk chocolate too. All those milk chocolate we have different shapes, different size, and the rest like that. Those were made using extrusion process too. Do you understand that? So that is that about that. So we use this technology in different. In fact, most of the food, most of the snacks we eat were made through what? Through this process. So that is that. So extrusion cooking is a high temperature, short time process. And I also told you that we can actually use cooling process also in extrusion process, then which reduces microbial contamination and inactivate enzymes. Because we are applying it, what happens? It can actually inactivate enzymes and even kill any bacterial infection, or sorry, any bacterial infestation on your what? On your food items. So the main method of preservation of both hot and cold extruded food is by low water activity of the product. What's the meaning of this? I told you right from the beginning that we have our extruder. So we have an extruder there. I mean, here, maybe one of these days we can have a visit, maybe to the lab. You can see the extruder. I think we have one or two. Then we order for one, but I don't know whether it's here or not. But we can check maybe later. Now, you look at this. This is the upper, right? From the feed upper, we feed our raw material inside. Let's say to produce. I don't know whether you've consumed this product before. Rice cereal, all the cereal that is made from rice waste. I think I bought one from Tesco the other time. So they will grind the rice, right? Put small water, right? Because when you are dealing with the extrusion process, the water quantity is what is minimal. That is the reason we will have thick shape. By the time it's coming out, it can dry easily, right? So now, so the water activity in extrusion is what? Is lesser. So that's what they're trying to say. So we don't need much water, especially in extrusion process. And so the water, okay, is by the low water activity of the product, and for a semi-moist product in particular, by packaging material that I was used. I think we are familiar with that. And extrusion bring gelatinization of starch, and most of the time, denaturization of protein. Like for example, we apply it, right? So for food items that are food are heat sensitive, when I say heat sensitive, it means that can be degraded under high heat. So extrusion process can actually lead to what? Denaturization or degradation, degrading of the what? Of the protein. Oh, wait. Is the voice? Can you hear the what's the name? Are you listening to the what's the name? Is the voice clear? Okay, good. So because I want you to have access to it later. Now, what are the advantages of what? Of extrusion technology? The first one is that adaptability. Now, the extrusion process is remarkably adaptable in being able to accommodate the demand by consumer for new products. What is the meaning of this? Now, uh, one of the shapes that are always attractive to children are star shape, right? And most of the time, in new product development, those are the things you should take into consideration also. So because of extrusion process, you can adapt your product to any design. And that is the reason you have different pasta or different shapes. Some are like this, right? Ring line. Some are like what's the name? Society. I think you like pasta, right? Yeah, you don't like it? Alright. I ate enough of pasta when I was Malaysia at that time, so I know we like pasta, right? And we even have shop restaurants. The only thing they sell there is pasta. So they are eat different pasta. So what I say in essence is that the production of pasta you can with extrusion process you can get different pattern, right? Either ring line. When we were young, we have all this cheese ball we put in our hand like ring, and we do like this, eating like this. You understand what I mean? And because of that, that brings fun. You understand? And that is because we have a technology that can conform or adapt our raw material to different work, to different shapes. And that is the reason why we say for extrusion, one of the advantages is that you can adapt it. Look at this one now. You understand like this? If you like, you can make it like this. You can make it like this based on what? Consumer preference. Exactly. So we can puff it, we can cook it, we can texture it, we can sterilize it, we can knead it, different applications. So that is one of it. So even if you have this maybe in a particular industry, the only thing you need to change if you want to form different shapes is to change this nozzle, right? So if it is a starlight nozzle, it will give you a starlight material. If it's a platelet nozzle, give you a platelet. See this one now. This is a tubular one, just like the turkeys. Some of you that eat turkeys, right? They have chili turkey, blue turkey. My daughter likes. She loves the blue ones, right? So all the different patterns you get is because thanks to this technology, extrusion technology. So do you have any question before we go? Let's continue. So now the next advantage of extrusion process is product characterization. Okay, characteristics. Sir, please don't copy and paste this. No. Because if you copy and paste it, the plagiarism will be high, right? So a variety of shapes, texture, color, and appearances can be produced, which is not easily formed using other production methods. I don't know whether it has happened to you before. If you are working with flour, you understand, you've mixed the flour and you want to form, it happened to me before anyway. If you want to maybe produce, let me say, which one? Have you ever heard of donuts before? Donuts? So is it easy for you to make donuts? And form it with hand? It's very difficult, right? Because there was a time my daughter told me, so Daddy, I want donut. So we got the flour. I tried to use my hands to make it like donut. And immediately I put it inside what? The hot oil. And I brought it up, everything brown and look good. That is not like that. And that's the reason why what we use as a mold, it's not there. I was not using my hand to mold it, right? But this technology will do all the molding for you, bringing your product out in different shapes. And that is one of the advantage, product characteristic. You can have your product in different shapes, different texture, color appearances, and which is not easily formed using other production method. Then energy efficient. So extruder operate at relatively low moisture while cooking food products. So less redrying is what is required. And that is the reason why when you put your raw material, maybe rice, waste, or whatever it is, inside your hopper, by the time it's coming out, because you are using minimal water, it will dry faster, right? And that is one of the advantages of extrusion technology. Then low cost. So extrusion has lower processing costs than other cooking and forming process. We can save 19% raw materials or 19% of labor and also 14% of capital investment from this process, because it is your extruder that will do everything. The mixing of the raw material, forming, right? The only thing you need is someone who will collect your product at the back, right? That's the only person you need. You only need the filler, person that will pour, what's the name? The feed, the raw materials, and the person that will get the formed material. And that is the reason why it reduces uh, labor, labor cost, and overall capital investment. So that is that about that. Do you have any question, please? Any question? Okay. Okay. Capital investment is more or less like the amount of money you need to operate your process, the production process. Take for instance, okay, maybe you want to establish a company that makes maybe bottled water, right? What do you need? You ask yourself, how much do I need to start this? That's it, right? So, and because you are using lesser labor, and uh, a minimal loss of the raw materials, then it means you have more products, right? And you gain more in terms of profits. And that's why we mention capital investment. And it's really cost effective. Then less space. So this is a typical extrusion system. So you just, in fact, the extrusion system we have at the University of Bath is just between this, just this. Imagine you have a production system or production plant as small as this. So it means this small room is enough to call your company, right? Precious Amadi Limited. And all your your production, what's the name, is just as small as this. Or Nije exhibition. So that is one of the advantages. So extrusion processing needs less space per unit of operation than other cooking systems. Then popularity. Why is extrusion process so popular? And let's just see this. When you get to maybe B&M, or you get to Tesco or Sainsbury's, and you just check the snack section, with what I explained now, you will discover that many of the products under the snack section, on this different snack section, they are made using what? Extrusion process. So, and this is due to the versatility, sorry, a wide ranges of products, many of which cannot be produced easily by any other process. It's possible by changing the ingredient, extruder operating condition, and dyes. These dyes is more or less like the nozzle, right? The nozzle you have there. Then you have the cost. So extrusion has lower processing costs and higher productivity than other cooking and forming process. And lastly, we have productivity. That's extruder can operate continuously with high outputs. They are extruder is one of the instruments I know that require lesser maintenance. Because I've worked with that equipment before. I will see what we do. So that's just about that. So do you have any question, please? Sniddy? Is it Shinde or Sniddy? Shinde, sorry. Because the first one and the second one, I will get confused. So the next one is mention cost. Then product quality. So see all these colorful products. See, The one that looks like you see that? Like orange slice, right? See, you can have different sizes, and the different sizes and shapes you have now determine the what? The uniqueness of your product, right? And that is the reason so many people now they like topics. Like Malik, immediately I mention topics. So, and it's because not because other products are better than topics. One is because of the kind of shape they use, the colorfulness of the bag, and even the texture. Right. So I spend money on topics. Always say for my daughter. She told me this, but then when I come with topics. And you see, and because of that now, the capital investment or the return of investment to that company will be high. And because now it has gained popularity, especially among all small children. Even if I don't want to buy it, my children will push me to buy it. And that is where uh, processing condition and whatever I want to do, that is where it comes. So once you have a good product, a good shape, texture, and drying and the rest like that, then we can have good output. So now it's environmentally friendly because as a low moisture process, extrusion cooking does not produce significant process effluents. In terms of the pollutants coming from there is less pollutants because whatever you are putting and you are getting out, right? The only thing you need to do is that once you finish your process, continuous process, you just need to wash. So that's all. So it's a simple process. So if you are looking into establishing an industrial environment, so you don't need many people. I think the only aspect you will need more labor or laborer are during packing, right? I think some of you do packing, right? So that is where you need more people. And when you even automate it, you don't need anybody, right? So that's that about that. So history of the extruder, I think there's no need to go into this. So then he's the first person, Anneli was the first person that Anneli was the first person that introduced extrusion. So he described the process for the production of spongy elastic particles from soya flour. And we have Atkinson also, we have Eldash and so on and so forth. These are the people that works with you. So Sai, so you need a new what's the name? New literature, right? Not don't give me 1964 literature. Because I know you are the one working on the illustration. So don't give me 1961 something or whatever. And then if there's any topic you are working on and you want me to treat in class, please let me know on time. So maybe next week. I think next week we have our guest lecture, right? I think it's a recorded class next week. So we have our guest lecture. I think after next week we have another guest lecture, right? I don't know if you'll be able to come because yes now. US is going, I mean Mexico now. Mexico is going. So I was still asking if you would be able to finish rules and things. You are doing the same voice with code. I don't know. So that is the history of the extruder. Then the principle. That's very important. The principle or mechanism of extrusion cooking. So the raw material are allowed into the extruder barrel and the screw then convey the food along. Now we have this let's say you have your rice, cereal, whatever you want to put there, you put inside. So the raw material aligned to this is a barrel, right? And the screw, as it moves, it conveys this until it gets to this point. So further than the barrel, smaller flight. And the reason why we call it cooking is because we have a raw material here. Because it's under heat. What happens? It will be cooked, and at the same time, it will form what? This. So it means we are cooking with minimal or lesser water activity. So that's that about it. So further down the barrel, smaller flights, restrict the volume and increase the resistance to movement of the food. So that is the mechanism. So the principle, as a result, it fills the barrel and the space between the screw flight and become compressed. So if the food is heated above 100 degrees C, the process is known as what? Extrusion cooking, or you call it hot extrusion. Do you understand me now? So I told you we have cold extrusion and we have hot extrusion, right? For some of you that are just coming, this extrusion process, this is the technology we use in producing noodles, in producing all this other thing, all these our snacks like turkeys, right? Like cheese ball as a pork product, like pasta of different sizes and the rest like that. So now we have cold extrusion and we have hot extrusion. For cold extrusion, this barrel will be heated, right? Sorry, for hot extrusion, this barrel will be heated. So this barrel, this compartment has different what? Heating capacity. So this one has maybe the highest heating capacity. So the heat chamber here, the heat is different from here. It's more or less like, let's say you have the first chamber, second chamber, the third chamber. The temperature here be different from the temperature here, be different from temperature here, right? So that is hot extrusion. So now, this part is what we call the pumping or mixing zone, right? So the temperature here will be different. Then moving to what? Melting, pumping, and also mixing zone. Side. If you want to draw this, possibly you can draw it. You can adapt it so that you don't have copyright issue. If you want to use maybe something like this, it's better you redraw it yourself. Maybe using AI or anything. AI can do this for you, right? Just tell me what I want to do, put it, and you can have your own. You can have your own picture. Just put a what's the name? Prompt. Then you can have your new picture. Because for your individual essay, so I will advise that instead of copying and pasting pictures, generate your own picture. Reason is that by the time we want to publish it, we have problem with copyright. Do you understand? Because that picture belongs to another person, right? So then the next one is what? Solid conveying zone. So under this part, we mix small amount of water also from the upper here. So we have the dry product here, and then we have the liquid cooling here. Then we get our product out later at the end of the day. So now, as a result, it fills the barrier and the space between the screw flight and become compressed in between this one because of the screw, the rotating screw. So as it moves further along the barrel, the screw need the material into a semi-solid, plasticized mass. So if the food is heated above 100, it's called hot extrusion. And for cold extrusion, we use cold extrusion most especially in products that can be easily degraded by heat. Let me give you an example of cold extrusion. I think there's something we always I've forgotten this thing called cold whatever that you think is, I mean, we do much of that when I was in India. They grind ice, right, and put a flavor inside, right. So for cold extrusion, we uh, grind that material under lower heat. Lower heat, what I'm saying is that like minus 50 degrees. It's more or less like you are mixing ice, right, in that material. And the reason why is that you don't want to what? Degrade your heat sensitive component inside your materials. So for hot extrusion, it's used only when you are dealing with food items that are not easily degraded by heat, right? But when you are dealing with food items that can be degraded by heat, right, you can use cold extrusion. Some of these products you see, Some of them are made through cold extrusion, some are made through hot extrusion. That's very, very important. So, and the reason why we use cold extrusion most of the time is that the frictional heat, because of the screw, right, can actually degrade your product. So we apply a cooling tunnel such that we can reduce the heat and get good material. So high temperature of operation in the presence of water promotes gelatinization of starch component and stretching of expandable components. So you discover at the end of the day, when it's coming out from here, it's coming out like this, just like a toothpaste, right? Because of what? Because it's already what? Gelatinized. It's mixed together, right? So that's that about that. So we have the ingredients here. We have the mixing here. We have the extrusion here. Then we have the dye here that gives out your what? The finished dried product. So, so this is the principle. So the food is then passed to the section of the barrel having the smallest flight, where pressure and sharing is what is further increased. So finally, it is forced through one of more restricted opening. So this is a restricted this is a restricted opening in the forming zone. And then we have our product coming out like this. So, and most of the time, we use steam most of the time to produce the water for mixing. So it's not just water we are mixing, right? The water is generated from steam, and from that steam, it is also generated, right? And then this will be mixed. At the end of the day, we get this out. So we are cooking at the same time we are forming something out. So what you see here, some of these products, they are product of what? Both eating, cooking, and what? Extrusion. That's why we call it extrusion cooking. So anytime you see cheese ball, right? It's a popped extrusion product or extruded product. Then when you have something like which other one? Turkeys. I think that's the one I remember. Right. Turkey. So they are what's the name? Extruded one product also. So that's that about that. We have many products that falls under this process. Then we all know this. Example of extrusion foods. We have pasta that is ready-made, ready-to-eat series, puffed series, and shredded series. Then we have snack products like corn, koi, puffed snacks, crisp bread, cold extruded products. Then pet foods also. So we have dry and semi-moist pet food. Then conventionally like what? Like toffee, caramel, peanut, Fritos, and the rest like that. Then we have texturized protein like meat analog. I think you've seen this before. Let's see if I can see that online. Because I saw something like that online. I mean, at Tesco, meats extruded products. So I want to see if I can have it here so you can see the. So an example, see this. So you can actually, I don't know whether I can say what put it. Okay, I think I saw it on Tesco. They put it inside one container like this. They put meat inside what's it? Inside the extruder, and they will grind the meat through extrusion, and it will come out like what do you call it? Ground beef. So it's more or less like a like and they pack it inside. And this is the extruded product also. That's analog extruded product. So the versatility of the what came with the adaptability is very high. You can adapt to any product. And this is the reason why you can never go broke if you have this kind of because if you like, if you are tired of soft material, you can move into other materials, right? So that's one good thing about this. And that's the reason why you get to B&M and other places like that, you can easily get different products because of this extrusion, however. So, pet food also, they are made from extrusion process. Then we have example of extruded food. We have sugar-based product like chewing gum. Your chewing gum. You see, there are many products. I can see your chewing gum. So chewing gum, fruit gums, all this your what's the name? Your gummy supplements and those things that you can use in the extrusion process also. So texturized vegetable protein, semi-moist and expanded pet food, and so on and so forth. You can actually use processed cheese also. You can use that one for extrusion process also. Pre-cooked composite flour, pasta product, pasta product, wheat bread, and croutons. All these we use extrusion process or products rather. Process for it. So the basic elements of proper extrusion cooking are the following. So we have the feeding of granular or milled material. So let me give you 5 minutes break, then we'll continue.